Hello and hi everyone. I welcome you to my YouTube channel Tech Basics. In the previous video, we have discussed about closure set of attributes and we also discussed about how to find a candidate key in a given relation. The link pertaining to those videos are available to you in my description part. I suggest you to watch those videos before you come for understanding the different types of normal forms. So let's understand over here what are the different types of normal forms which are available to us. Types of normal forms that are available to us are we have first normal form, we have second normal form, we have third normal form, followed by Boyce code normal form. Apart from this, we'll also try to understand what exactly is fourth normal form all about and what is fifth normal form and so on. So let's get into details about the first normal form. When we talk about first normal form, we need to follow certain rules which are mentioned over here in order to say that a given relation exists in first normal form. While we create or we design a database, we are supposed to follow certain rules which are simple in nature, easy to understand. And these rules are the first one is to say single value attributes, which means each column of our table or relation should be a single value, which means they should not contain multiple values. Let's understand this with an example. For example, if there exists a column called phone number, then there should be only one value for phone number and not multiple values for that. Similarly, there should be only one value for a column called address column and so on. So I'll get into details about this with an example in the next slide and so on. The second rule over here says attribute domain should not change. So this is more of a common sense rule. In each column, the values which are stored should be of the same type and so on, same kind or same data type. You should not have a column wherein you have some numeric values and you have some character values over there and so on. So that's the second rule. The first rule says you need to have a single value attribute. No two column should have multiple values. And the second rule says attribute domain should not change. That means in a given column, all the values should either be numeric or character and so on. Take an example for this. If we have a column called date of birth, to save date of births of set of people, then we cannot or must not save the names of some of them in that particular column along with the date of birth in that particular column. It should hold only date of birth for all the records or rows and so on. That means if a column is prescribed to store date of birth, we should have only the date or the date of birth for all the people over there. We should not have a mix of names along with date of birth in a single column and so on. Rule 3 says over here, unique name for attributes or columns. So whenever you create any table, you should see that all the attributes do have a unique name. Otherwise, it leads to the confusion while you try to retry the operations on database and so on. It will leave our database DBMS system in a confused state and so on. So what all we need to take care, we need to see that every attribute has to go with a different name. Rule 4. Order does not matter. This rule says that the order in which you store the data in your table does not matter. So you can store the data in any order. Later, if you want, you can change the order of the data that you store in a particular table. So there are 4 rules that we are trying to understand over here. Rule number 1 says single value attribute. The second rule says attribute domain should not change, and the third says unique names for attributes or columns, and the fourth says the order in which the data is stored do not matter. So take an example over here. There is an example of a relation called employee. You call it as employee table or employee relation. wherein you have attributes like employee ID, employee name, employee phone, and employee state. So if you see over here, you got unique values or only one value for a column called employee ID. Each employee is having only one ID over here. Each employee is having only one name. Whereas if you come to this phone number, an employee is having more than one phone number. As we said in rule number 1, this is not allowed. So this particular table or the relation that we have designed is not in first normal form. So what is that we need to do? We need to decompose this so that this particular relation comes into first normal form. How to do that? So what all we need to do? We need to take the employee ID, we need to take the name, and there are two phone numbers over here. So you need to separate them. You need to write the first phone number over here, followed by the name of the state. Similarly, for the same employee, same name, you will write the second phone number and the name of the state. The same thing you will do for employee ID 12, because there is a repetition or there are multiple values of phone numbers for employee 14 and employee 12. So if you bifurcate this, then you will have more rows over here, but you can now say this particular relation exists in first normal form. This relation satisfies all the rules that we stated for first normal form, wherein you will have unique attribute name, one value in each of the column. In a column, all the values are of same data type, and so on. Then we'll try to understand second normal form. So before I get into details of second normal form, we'll just repeat the rules of first normal form once again. We say a given relation is in first normal form if that particular relation satisfies these rules. Rules are like single value attribute. Attribute domain should not change. The third rule is unique name for attributes are columns. And the fourth one, we know this, order does not matter, and so on. So these are the four rules that we need to remember in order to say that a given relation exists in first normal form. Yeah, then we'll try to understand what exactly we mean by second normal form. When do we say that our relation exists in second normal form? In the second normal form, 2NF, you can call it as, relation must be in first normal form. So if you have to find out, or if you want to say your relation is in second normal form, basically it should be in the first normal form, and all the non-prime attributes should depend on whole of candidate key and not on partial key. So what is the next point over here? All the non-prime attributes of your relation should depend on the whole of candidate key and not on partial key. So let's try to understand this in detail. If an attribute depends only on part of candidate key, then it is called partial dependency. So try to remember this point. If an attribute depends on only part of candidate key, then it is partial dependency. And if there exists partial dependency, then we say your relation is not in second normal form. So there are many new terms that we come across over here called prime attribute, non-prime attribute, partial key, partial dependency, and all. Let's try to understand all these terms with an example over here. Take an example wherein you have a relation over here having four attributes A, B, C, D, and so on. And there you find some functional dependencies which are given to us, wherein there is a functional dependency from A, B to D, and a functional dependency exists from B to C. So we'll be given a relation and we'll be given some functional dependencies. Then we are asked to find out whether this particular relation exists in a particular normal form or not. So for that, what is that we are going to do? First, we are going to find what are the essential attributes and the key, candidate key for this particular relation. So we have discussed this earlier, how to find the essential attribute, how to go with the closure set, how to find the candidate key in my previous videos. So the essential attribute over here for this is AB, and the AB itself, when you find the closure, it can search all other attributes. That means AB is going to be the primary key, the candidate key for this particular relation. So when AB is a candidate key, what we say over here is the attributes which are a part of your candidate key, they are called prime attributes. So AB, when we say it is a candidate key, AB we call it as prime attributes, and rest of the attributes which are there in our relation, we call them as non-prime attributes. So we know now what is prime attribute and what is non-prime attribute. Prime attributes are those which are part of your candidate key. Non-prime attributes are those which are not part of your candidate key. So if you go by this now, all non-prime attribute should depend only on whole of the candidate key and not on a partial key. So what do we mean by this? So the prime attributes in our relation are AB, non-prime attributes are C and D. Now let's find out whether the non-prime attribute depends on prime attribute on a whole basis, or whether they depend on part of the prime attribute and so on. So let's try to understand that. There exists a functional dependency from AB to D. That means D is dependent on AB, where AB is a prime attribute and AB is a candidate key over here. So what is that we want is every other attribute of our relation has to depend only on the candidate key and not on the part of the candidate key. So in this case, D depends on AB, where AB is a candidate key. Whereas when you talk about B and C, C over here depends on B, wherein C is a non-prime attribute and B is a part of your candidate key over here. So there exists a relation over here, there exists an attribute over here which depends only on part of your candidate key and not whole of the candidate key. In this case, we say there exists a partial dependency over here. So here what we are saying, in the first case, D depends on AB. So no issue because AB is our candidate key. Whereas C depending on only B and not on AB. So if C depends only on B, where B is partial key and not whole of the candidate key, then we say it is partial dependency. So if there exists a partial dependency, then we say the relation is not in second normal form. I'll come back again. In order to say that a relation is in second normal form, the relation has to be in the first normal form. Okay, all non-prime attributes should depend on whole of candidate key. Understand this. All non-prime attributes should depend on whole of candidate key and not on partial key. So this is where we need to remember things. All non-prime attributes should depend on whole of candidate key and not on partial key. If an attribute depends only on a part of a candidate key, we are going to call it as partial dependency. So in our case, AB is our candidate key. So D depends on AB is not a problem, but C depending only on B and not on AB is going to be a problem, which we are going to call it as partial dependency. And if there exists a partial dependency in our relation, we say the relation is not in second normal form. So if the given relation is not in second normal form, what is that we are going to do is we are going to perform decomposition of this particular relation. So what is that we do then? When we can find the value of A, that is value of D with the help of AB, what we do is we'll try to make ABD as a relation R1, and then when you can find the value of C with the help of B, we'll try to make it as one more relation called R2. So now this relation, when you decompose into R1 and R2, this relation exists, we can say, in second normal form. So what is that we are trying to say in second normal form? Relation is said to be in second normal form only when it is present in the first normal form and there exists no partial dependency in our relation. Then you say it exists in second normal form and so on. Let's try to solve this particular example over here. There is a relation given wherein you have attributes like A, B, C, D, E, and the functional dependencies which are given AB, functional dependency from AB to C and D to E and so on. Now here you try to find out the essential attributes and try to find the closure of this. So essential attribute over here is ABD, and when you try to find the closure of this, it is ABCDE. That means ABD is going to become, or it is going to be a candidate key for us, because with the help of ABD you are able to get the values of all other attributes over here. So ABD is your candidate key. When ABD is your candidate key, then rest of the attributes are called non-prime attributes. Now what is that you need to check is whether a non-prime attribute is dependent on whole of the candidate key or part of the candidate key. So see over here, C is dependent on AB. What is our candidate key? ABD. But C is dependent only on AB and not on ABD. So it is called partial dependency. So if there exists as partial dependency, at least for one time, in one of the case, then you can say your relation is not in second normal form. If you go with the other example, E is dependent only on D and not on ABD. So it is again an example of partial dependency. So when there exists a partial dependency, your table is not in second normal form. So what is it we are going to do? We are supposed to decompose this. So when you try to decompose this, we know that ABD is our candidate key, and we know that we can find the value of C with the help of AB. So you can make ABC as one relation, call it as R1, R2, and then D can find the value of E, so you can make it as the other relation over here. But if you have only these two relations, you cannot join this and try to get the values from this, because there is no common attribute in this. So what is that we need to do is, we need to make one more relation with the help of a candidate key. So you will decompose this into three relations, R1, R2, R3 and so on. So the rule of second normal form says there should not be a partial dependency within our relation and so on. So try this particular example, or we can go with this example and then I'll give you one example to solve. Try this. How we can do this now? Relation called ABCDE is there with attributes ABCDE, and there are functional dependencies from A to B, B to E, C to D and so on. So then here you can see that the essential attribute is AC. AC is an essential attribute, and AC is able to search the values of all other attributes, can find all other attributes. So AC is going to become your candidate key. So when AC is candidate key, we call AC as prime attributes, and rest of the attributes are called non-prime attributes. So here you can see now B is dependent only on A, whereas our candidate key is AC. So B is dependent only on part of candidate key. So there is a partial dependency over here. Now in the next case, E is dependent only on B. So neither this is prime nor this is a prime. Here E is non-prime and B is also non-prime over here. So when both are non-prime, we do not have any issue of partial dependency and so on. Now coming to the next one, D depending only on C, where C is a prime attribute. So if a non-prime depends only on a part of the candidate key, we call it as partial dependency. So in this case, again you will say your table is not in second normal form. So what is that we need to do for this? We need to decompose this table with the with different relations called R1, R2, R3, and so on. Okay, so how is that we are going to do? AB. With the help of A, you can find the value of B, and with the help of B, you can find the value of E. So what you can do is you can put A, B, E into one relation, and then with the help of C, you can find D. So you can put this into another relation, and then the candidate key will occupy one relation. So this particular table or relation can be decomposed into R1, R2, R3, and so on. So this is how you are supposed to find out whether a relation is in second normal form or not. If it is not, then you are supposed to decompose that particular relation over there. So if you feel that this particular video is useful to you, please share it with your friends, and if it is useful to